All right, let's talk about AI code assistants. They often feel like, well, like straight up magic, right? One second, you're completely stuck on a problem, and the next, bam, the perfect code just materializes right there in your editor. But here's the thing, it's not actually magic. And today, we're going to pull back the curtain and show you exactly how the trick works.
So, to really wrap our heads around what these tools are doing, let's try an analogy. Don't think of them as some kind of all-knowing oracle. Instead, I want you to picture a super smart, and I mean incredibly fast intern who basically lives inside your code editor. This idea of an AI intern, that's the key. That's going to help us understand everything that follows.
Okay, so let's start with that user experience, because the first time you use a really good AI assistant, it feels genuinely magical. It's like it can read your mind, right? It just seems to anticipate what you need, it understands your code, and it spits out solutions almost instantly. So what does that interaction actually look like from your side of the screen?
Well, the workflow feels just brilliantly simple. You just ask a question in plain English, something like, hey, why is this endpoint so slow? The tool then appears to scan your entire code base, it pinpoints the problem, suggests the exact changes you need to make, and then, with your okay of course, it applies those edits across a bunch of different files. It just feels like it works, seamlessly.
And the core of that magical feeling, it really boils down to this one key idea. It seems like the AI can see and understand your entire project, your whole repo, all at once. But is that really what's happening? Well, that's the big secret, isn't it? That's the magic trick we're about to break down.
Okay, so we've talked about the what it feels like to use one of these. Now it's time for the how. We are going behind the curtain to see the actual mechanics of the trick. Because, as you've probably guessed, what feels like magic is really just a very clever combination of specific technologies all working together. And you might actually be surprised to hear that this whole magical experience, it really just boils down to 5 core building blocks. That's it, just 5. And once you get these 5 concepts, you'll know exactly how your little AI intern thinks and gets its work done. So yeah, let's unpack that secret. These are the 5 pieces of the puzzle, the building blocks that power pretty much every modern AI code assistant out there. We're going to take them one by one. First up, we've got API calls. Okay, at its absolute core, the tool is just a messenger. It takes whatever you ask it, and it sends it through a paid gateway, that's the API, off to a huge large language model, something like GPT or Claude. Then it just waits for the text response to come back and shows it to you. That's step 1. So what this is really doing is just automating a super tedious loop that we've all done. Without the tool, you'd be manually copying a chunk of code, switching over to a browser tab, pasting it into some chat window, getting an answer, and then copying it all the way back. The assistant it handles that entire round trip for you, without you ever having to leave your editor.
All right, now for the big one. This is the real secret sauce. It's called context injection. And here is the most crucial point to understand. The AI model, the big brain in the cloud, it doesn't automatically know anything about your repository. Nothing. It only knows what you send it in that one specific moment.
So let's imagine you type in a simple question, something like, why is my caching flag not working? It's short, it's direct, but think about it. That question assumes a ton of knowledge about your specific project, right?
And here is the trick. The tool doesn't just send your little question off to the LLM. Nope. First, it intelligently searches your project for any files that might be relevant, like your feature flag configuration or your caching class. And it injects the code from those files right into the prompt along with your question. That's how it knows your repo. It's not seeing everything, it's just being shown the important bits. Building on that idea, we have building block 3, tool calling. This is super cool. It basically gives the LLM the power to ask your editor to do things for it. It can effectively say, hey, editor, search these files for me, or go run the unit tests and tell me what the output is. So your AI intern isn't just a know-it-all, it can actually be a doer. Next up is memory, but it's really important to know that this is not like human memory. Session memory is just short-term. It's remembering what you and I are talking about right now. Saved memory is more like a long-term notepad. The tool might jot down a note that, hey, you prefer to write your tests using a specific framework. Then it'll inject that little preference into future prompts to make its suggestions even better for you. So that begs the question, how does it even find the right files to inject in the first place? Well, that's our final building block, repo indexing. Now, on the simple end, it can just use a keyword search. Think of it like a super fast Control-F across your whole project. But the more advanced tools, they use something called semantic search. This is wild.
It means you could search for, say, database connection logic, and it would be smart enough to find a file called dbhandler.py, even if that file doesn't have those exact words. It searches for the meaning, not just the text.
So, okay, now we know how the trick works. But that leads to a much bigger question, doesn't it? It's about the hype around all these tools. The demos always look absolutely perfect, social media is flooded with success stories, and honestly, it can create this real pressure. This feeling like if you're not already an expert, you are seriously falling behind.
And look, this is a question a lot of developers are asking themselves right now. The buzz is absolutely huge. Social media is just packed with these seemingly magical results. So why does it create this pressure, this feeling that you're missing out on the next big thing? Well, the answer really lies in the huge gap between the polished demos and, well, reality. The demos show you this effortless, magical workflow, but what they don't show you are the hidden costs, like token costs, where every single request you send to the AI costs money based on how long it is. They don't show you all the wrong suggestions or the times it completely breaks the build, and they definitely don't talk about the serious security constraints that stop a lot of companies from even touching these tools.
So, when you put it all together, the secret formula isn't one single magical ingredient. It's the combination of all these parts. It's a nice UI in your editor that uses smart indexing and search. It uses context injection to feed the right info to the big language model, and that model can then use tool calling and memory to give you a really relevant answer. That's it. That is the whole trick. So, now that you know the secret, you can see these tools for what they really are. Not some mystical force, but incredibly powerful automation. They're like that super useful intern we talked about. But they're still interns, right? They make mistakes, they cost money, and they definitely need supervision. So the real question to ask yourself isn't, am I using the magic? The better question is, how can I be the best supervisor for my new AI intern?